All right, so today we're going to look at a little bit of Calc 1 review. To begin with, we have a piecewise defined function here, and I'm asking what's the limit as x tends to 1 from the right of my function? Well, if I'm to the right of my function, then I have to use the rule 3x, and the answer is 3 times 1, which is 3. If I ask what's the limit as x tends to 1 from the left of f, if I'm to the left of 1, then I'm a little bit less than 1. I have to use the rule x plus 4, so the answer is 1 plus 4 equals 5. If I ask the question, what's the limit as x tends to 1 of f? Well, since the limit from the right is different from the limit from the left, I have to say this limit does not exist. And if I want to know the value of the function at 1, well, at 1, I have to use the top one. So it's 1 plus 4 is 5. Now let's compute some limits of some rational kinds of functions. Suppose I want the limit as x tends to 0 of sine 5x over 2x. Well, if I just plug in 0, I get 0 over 0, which I know is indeterminate form. Indeterminate form allows me to use L'Hopital's rule, so this limit is the same as the limit as x tends to 0 of the derivative of the top, which is 5 cosine 5x over the derivative of the bottom, which is 2. And now when I plug in 0, I get 5 cosine 0 divided by 2, which computes to be 5 halves, since cosine of 0 is 1. The next problem, if I want to compute the limit as x tends to minus 1 of this fraction right here, I notice that if I plug in minus 1, I get 0 over 0 again. So I have several options. One is I could multiply things out, use L'Hopital's rule, or I could use the product rule on the top and the product rule on the bottom, but that's very hard. I also noticed that since I gave it to you in factor form, that the x plus 1's cancel. So this just becomes a limit as x tends to minus 1 of x minus 2 over x plus 3. Plugging in minus 1, I get minus 3 halves. All right, now let's look at computing derivatives. So this first derivative, I realize I'm going to have to use the what? Chain rule. So it's going to be twice the inside. And then the chain rule says times the derivative of the inside. And that's how I get my answer, 2 times 5x squared minus 3x times the quantity 10x minus 3. So when I differentiate garbage squared, I get twice garbage, and then the chain rule says times the derivative of garbage. All right, the next problem is a little more complicated. The derivative of sec squared, the hyperbolic secant squared of 3x. Chain rule again, this time the outside operation is sec squared. How do I differentiate that? 2 times sec of 3x. Then I have to differentiate sec of 3x, and the derivative of the hyperbolic secant is minus this hyperbolic secant hyperbolic tangent. So I get minus sec 3x tangent 3x. And then I have to continue with the chain rule, and I say multiply by 3. When I clean things up and combine the hyperbolic secants, I get minus 6 hyperbolic secant squared times the hyperbolic tangent times 3x. And that's the way we do that one. Next, I want to do the derivative of this fraction right here. This is going to be an application of the quotient rule. What does the quotient rule say? Low d high. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Cleaning things up, my 2x's cancel upstairs. I get a minus 2 over x minus 1 all squared. And that's as far as we got in the first lecture.